Hello, everyone. Welcome back to the Next Frontiers of AI podcast, where we speak with the pioneers shaping not just the future of AI, but how we navigate the uncertainty around us. Thanks for joining us today. I'm Scott Hebner, the principal analyst for AI at theCUBE Research. In this episode, we'll delve into the challenge that most tech and business leaders face. How to make sense of what's real across the AI landscape. What's hype? What's myth? And where's this all actually heading? It's clear to us here at theCUBE Research that many are not getting the signals within the noise of the marketplace. With innovation cycles moving at warp speed, you can't afford distractions or to fall behind, because if you do, you may never catch up. We're at a defining moment, what many are calling the golden age of AI agents. Vast new opportunities are taking shape, where intelligent digital coworkers, systems that can reason and collaborate alongside humans and even operate autonomously when needed. In addition, innovators can now build 10 times faster and deploy products at scale with significantly fewer resources. Unlike the cloud and SaaS era, the democratization of AI has changed everything. There is no doubt that we are in the dawn of a new super cycle in business innovations. And for many leaders, they're struggling to get clarity on what to do and how. What matters the most? What's coming next? And how do you design a journey that avoids the hype trap and creates long-term value? In other words, where do you place your bets? Well, today we'll unpack all this with someone who's building on the front lines of this transformation. I'm thrilled to have Dr. Satya Nitta join us today. He is the co-founder and CEO of Emergence AI, the providers of intelligent agentic systems designed to automate complex workflows. With over 15 years of experience in AI, he has led groundbreaking advancements in conversational systems, natural language processing, and AI hardware, and has to his name the IEEE Innovator of the Year and Technology of the Year awards and over 100 US patents and 40 plus publications. Super qualified for this conversation. So Satya, thank you very, very much. It's an honor to have you here. Let me kind of bring you up on the screen here. There you go. Welcome.
Thanks, Scott. Pleasure to be here.
Yeah, I'm really glad that we got to talk over the last week or so and get to know each other. I think this is going to be a fascinating conversation, and it was also interesting to find out that we spent a lot of time together at IBM, that big, massive company.
Indeed, yeah. I have very fond memories from my time at the IBM Watson Labs. I spent 18 years there.
Yeah, and I was there at the same time, except I was in the software group. So we were. By the way, do you know Danny Saba?
Yes, I don't know him personally, but I know who he is. Yeah.
Yeah, he was one of my general managers at one point. So he was our connection into the world of research at the time.
Yeah, he used to come there. He used to come to the labs quite a bit.
Great guy. I've learned a ton from him. My favorite expression from him was, "Do you want to be right or do you want to be effective?" which are two different things.
I think I choose effective.
Yeah. In other words, you can't always argue endlessly that you're right. Sometimes you have to. Yeah. But anyhow, for our audience, before we kind of get into our conversation today, that's going to be about what is hype, what is myth, what is truth out there in the world of agentic AI. Tell us a little bit about the journey that you've been on and how you ended up now where you are at Emergence.
Sure, yeah. So I spent, as you said, Scott, I spent 18 years at the IBM Watson Labs. Started my career as a nanomaterials guy. I have a PhD in nanomaterials formally, and so I spent about a decade advancing Moore's law. So I morphed into a nanoelectronics guy, into a broader applied physics guy. And then I ended up working on a branch of computing called neuromorphic computing. That was my entry into AI, and it was actually, I didn't know it at that time, but my entry into AI was very well timed. Watson had just won Jeopardy. AlexNet was about to win the ImageNet competition, and deep learning as a field was being born. I mean, obviously, Hinton published Deep Belief Networks, I think, in 2006 or something, which was a groundbreaking paper of that time. And I just followed, kind of what was really exciting and interesting to me at that time. I was in the lab, moving up the ladder and finding research problems that were things that I genuinely enjoyed working on, and AI. And I realized after working on neuromorphic computing for a little while that all the action was in algorithms, and that's when I basically jumped into AI. And it's ironic that 15 years later, we're now talking about some non-mononomial architectures and how to, accelerate, machine learning inference and so on and so forth. And we were 15 years ahead of our time and solving problems that weren't fully there then, but they are now. So.
Yeah, and that's the way I view it, is a huge learning experience. I think some of the propagations that, we were going to solve cancer and world peace. I think it was overpromised too early, and then, but definitely catching up now. That's for sure.
Yep.
Well, let me kind of set up our conversation here, which is what's happening out there in the marketplace. We went through what, 10 years perhaps of people starting to put predictive AI models in place. And then we got over the last 3 years into generative AI. I think that democratized it for, a lot of people. People have an appreciation for it now, what it can do. It's delivering marginal ROI, I think, in enterprises, right? Mostly around individual productivity. But things have really sped up over the last, couple of years. And now we're getting into agentic AI, and there's just a ton of terms, a ton of points of view on what it is. I think it's confusing. As I keep track of the discourse out there, there's different opinions, there's different definitions. And it's not surprising to me that 75% of business leaders, lack the clarity that they need on their journey ahead, where to head with all this stuff. And that's sort of, I think, what we want to talk about today, right?
Yes, yeah, absolutely. Look, I'm not surprised. There's so much noise, and at the end of the day, what was always true, even back in the day with Watson Scott, the journey you and I shared uh, 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 during our time at IBM, was what wasn't clear about AI was how will this technology improve outcomes that really matter for enterprises, right? And so we couldn't articulate it well then. I'm not sure people are articulating it any better now, a decade later. It's still mystifying to enterprises about, what should I do with AI? How will this impact my business? How will it move the needle on outcomes I care about? How will it make me more money or save me more money? And there's a lot of value to be unlocked here, but unless you basically draw the line between the connecting threads between what the technology is capable of truly and the outcomes that really matter, you're not going to unlock that value.
So how would you define, let's start with a business leader, right?
Yeah.
How would you define the emergent agentic AI marketplace, what it can do, what its value is, and more importantly, how is it different from what they've sort of gotten exposed to over the last many years with agentic AI and LLMs?
Yeah. I mean, look, Emergence as a company is focused on essentially a small set of problems in kind of the IT back office, you could say. Okay, or if you look at what enterprises do on a daily basis, there's a large number of projects that they work on, which are essentially doing things like systems migration, systems integration, uh, data migration, even writing ETLs. Um, and these are all served, so these are existing problems that enterprises are paying for. So that's the first thing, so which is it's one of the hardest things in the world is, it's very hard to create new technology and a new market at the same time. You can create new technology to serve an existing market, that's a bit easier, or you can basically create new market for existing technology, which is also a little bit hard, but nonetheless it's easier than building new technology and inventing new use cases and new markets at the same time, right? So kind of the reason we are going after something like the IT back office or IT automation broadly is these are existing spends, existing problems. Enterprises know what it means if they were to migrate data, update their systems, get more value out of it, and what the impact on their business is, and they're willing to basically deploy some money in the process of doing it. So today, that entire thing is met by a variety of technology companies, broadly IT services companies, everybody from IBM to Oracle to Wipro to Cognizant, etc. And the promise here is, and the delivery happens through a large human labor pool that basically does a lot of coding jobs. And so that brings us kind of what AI is really great at. But so the promise here is agentic AI or agentic coding can actually do a subset of these jobs and do them just as well,
Right.
if not better, and do them cheaper, do them faster. And so Emergence's value prop to enterprises is we will deploy your IT services for you better, cheaper, faster, basically.
So it's sort of like the generative AI, task oriented, especially for repeatable tasks, more individual focused, and it's a productivity tool for an individual. Where agentic AI takes on more characteristics of how a human worker would do something. In the case you were just talking about, is building applications and systems integration and doing a lot of the heavy duty work, because they become more intelligent or more educated, and they're able to do more, and they're able to participate in a workflow, not only among each other, but with humans. I mean, is that how you would sort of?
That's how I would exactly, right. And at the heart of it, if you will, what's actually really happening is, I think one of the things that LLMs are actually really good at, they're not great at a lot of things, but one of the things they're good at and they're getting better at all the time is coding jobs. Okay.
Mhm.
um, and on the face of it, you'd say, okay, look, what do you mean they're getting really good at coding? They are able to produce code, okay, but you still need a human in the loop to go correct the code and update the code, and of course, the more complex the coding job, the more difficult this whole thing becomes, okay. And here's where we're bringing agents into the loop. We're kind of saying, look, if you do something like agentic coding, which is get an LLM to produce some code, get an agent to basically validate that code, verify it, go back and figure out what's wrong, and reproduce code. You're kind of taking the developer's role with a human in the loop. Okay, and so for a small class of problems, of course, the promise here is gigantic, and then the promise is, and then the technology isn't fully there at all. But for a small class of problems, uh, in agent in Python, etc., we have basically gotten very good at agents helping code, and agentic coding becoming real to a point where we can do some of these tasks we talked about, some data migration stuff, systems implementation, systems integration stuff, pretty well. And that starts unlocking a pretty big opportunity. Okay.
Yeah, ton of value, right?
Yes.
So are we moving away from the one model rules them all, like ChatGPT, to systems of intelligent models and agents that are all working together, sort of an ecosystem that's built around it?
Yeah, I think we already have. Okay, so Scott, you are aware of some of the work that existed in AI in a previous era around cognitive architectures and so on, and we discussed Minsky's Society of Mind, etc. Um, what's been true about AI from that time through the last through kind of the deep learning era to the generative AI era is that most successful AI systems are exactly that. They're systems. They're not one model, they're not one algorithm. They're a set of models, algorithms, modules that all
Mhm.
come together to solve a problem. And systems have aspects of determinism, they have aspects of reproducibility, they have aspects of long-term memory, governability, all these kinds of things. Okay, and if you get them right, then these things are actually capable of doing some pretty profound things. But at the end of the day, these are all systems. And examples of what's happening today, where things like if you hit a what you think you're hitting, which is an LLM like a Chat GPT, you're not really hitting an LLM. You're hitting an agentic system. The LLM is buried way below, but
Mhm.
what you're really hitting is an agentic system that's fine tuned to doing a set of tasks for the consumer. Okay, and in some level, at some level, Emergence is doing something very similar, except our target isn't the consumer; it's the enterprise user and a certain class of enterprise users. And we are building agentic systems. Other examples of agentic systems are self-driving cars. One of the best examples of agentic systems out there. So yeah, so we have. I don't think we're talking about models at all anymore. Now, at least in the at the forefront of the field. Now, with respect to enterprise adoption, it's a different issue altogether. I can get there in a second. But we're certainly in an era where there's more and more, acceptance of the fact that it's not one LLM, one model, one algorithm. It's an ensemble. It's an intelligent system, well built, that will solve really serious problems.
Yeah, I think that's right, because every business, every industry, every domain, every country. I mean, there's going to need to be some unique characteristics and knowledge and intelligence for each of those, right? Very domain specific, and that's why I've always thought of Gen AI as sort of being the equivalent to the browsers in the early internet age. The browsers basically created a gateway into the world of online. Gen AI is creating a gateway into the world of AI, and it has all, like you said, the general purpose consumer-based knowledge, right? It sucks up the internet and beyond. But if you're going to do something in your enterprise for your customers, in your industry, in your business model, in your products, you're going to have an ecosystem of models and agents that are specific to you. And therefore, it's not going to be a one size fits all. You got to have an architecture, because it really matters, right? Do you agree with that?
Completely, yeah. I mean, exactly.
Yeah.
I couldn't agree more. All cognition is domain specific, context specific, right? Whether it's human or machine cognition, and so we fully subscribe to the perspective that domain grounding and context understanding is absolutely critical for any of this AI, agentic AI, or even just pure old LLM based generative AI, for it to be useful and effective and produce real ROI for people.
So let's I'm going to show you a chart here, some of the research I did looking at a whole ton of different surveys out there about what do people view as being the most important technologies going forward to enable agentic AI. And you can see here at the very top is, obviously the generative AI, the LLMs, right? Which, you can see the numbers in terms of relative importance. But what's your thought on this research? It seems to me as you go down the stack here, you get into more sophistication.
Yeah, I mean, so I think it's on the money. I mean, I see a couple things missing, like long-term memory, etc., and context and domain understanding, which we just spoke about. But
Mhm.
in particular, I know you and I both share a real interest in reasoning. So some of the decision intelligence, causal reasoning, uh, agentic reasoning. I think that's kind of where the action is from an
Yeah.
enterprise's perspective. Unless you can actually explain how these things are coming up with some decisions, how they how you can audit them, how you can correct them, I doubt that they will actually be very excited about just the promise of the technology. It's really about governance, about auditability, about trust, about safety, and ultimately, most of all, it's about outcomes, right? So
Right.
if you get them all together, then you can unlock enormous promise, enormous potential with this technology. The promise is there, but there's a long way to go to fully unlock it.
Yeah. And you and I, and certainly a lot of people watching, have lived in the technology industry for a long, long time. And, there's so many new technologies out there right now, and people are defining them differently. And and I can see how people, like, I got to put all these pieces together. And one of the things that really has been a focus for me is we have chain of thought, right? People are calling that reasoning, right? And it's still correlation based. And if it doesn't really understand consequences, it can't make a judgment. You need judgments to make a decision. But it's sort of a first step on that roadmap. So I think to do everything that you talked about earlier, going from a task to achieving a goal, and being helping a human do more than just generate a task like generating code, but actually design and implement a system. It's going to have to make decisions. It's going to have to understand the goal you're trying to achieve and help you problem solve. And I think that's where this stuff, my 2 cents is that's where it's headed in the years ahead. And I want to get your view on this diagram here, where I think we're at the chain of thought layer now, which is a step on that ladder, if you will, to more and more capable reasoning, and semantic reasoning being knowledge graphs and all that stuff. But what are your 2 cents on where this is heading in terms of reasoning? Right, never be like human beings, but progressively more capability to help humans reason is probably a better way of saying it. Where are we now, and what are the key things you see happening?
Yeah, I mean, I think I think I agree. I agree with this progression of gradual increase in reasoning capability of intelligent systems. From our perspective, you're exactly right. Just to pick up on the fact that these things don't really reason like people, but it doesn't. It really shouldn't matter. At the end of the day, the reasoning is about achieving an objective, solving a problem, right, fulfilling a task, and so on. And I think multi-agent reasoning, and in particular bringing in context awareness, domain groundedness, and then explaining. So if you basically are an LLM and you produce some output, or an agent and produce an output, you should be able to explain how you got there. You should be able to trace the agent's reasoning path, and you should be able to say, based on this data, based on this understanding of the domain, based on this SME knowledge, I've produced this output. So it's getting better now. Are these going to reason like people? I don't really think it matters. Okay, if you there's a very robust I think debate in the AI literature. Certainly, Rao Kamampati and people who maintain that language models don't reason, or agentic AI doesn't reason. At some level, I mean, human reasoning itself isn't fully well understood, right?
Right.
So, and at some level, as an engineer, I don't really care. What I care about is, will this solve a task, and will it give me a reasonable understanding of how it got to that answer, right? And that capability is certainly evolving rapidly, and it's certainly getting to a point where we can do some very complex things like analyze gigabytes, hundreds of gigabytes of structured data, or even unstructured data, and come to some conclusion and explain how we got there. I think that's a great example of systems that can reason to a point where a human would say, "I'll trust what these things came up with."
Yeah.
I think another example of the frontier. I think one of the things we discussed, and one of my favorite examples is AlphaGo and Move 37, and so machines are capable of reasoning and coming up with very surprising leaps that humans aren't. Right. So I do think there's a capability here that's evolved. AlphaGo is now nearly 8-9 years ago. It's been kind of this beacon for the entire field in many ways. I think the ability for machines to reason, to solve problems, to explain themselves, it's coming along quite significantly. And at some level, the debate about do these things really reason or not, I think it's a little bit academic from my perspective.
Yeah. And I think that's one of the things that gets me excited about the causal inference, right? Or the causal knowledge graphs, is that you have an LLM, then you can feed a causal knowledge graph that understands cause and effect, and that can actually describe the precise chain of events that leads to an outcome. It sort of opens up the black box, but it does it in a way that it does it only for what's domain specific for you. But and so I think there's like these little things, little increments that are moving forward in time here that are going to give us more and more of that capability. Because I think you're right. Trust is the currency of innovation. No trust, no ROI going forward, increasingly. And if it can't explain itself, and you don't understand how it's, recommending a decision, you're going to be less likely to trust it. So it's got to get
Yep.
solved.
Yep,
Yeah.
yep, 100%. Yeah, completely. And that's really about, and that's why the discussion about reasoning is germane, because how do you build trust? You build trust by tracing, a set of decisions and showing how each conclusion led to the next one, and ultimately this is the output, and making that verifiable, making that governable, making that auditable, allowing humans to correct it. All of this is what will build trust. And I think you had a stat, wasn't it, about how enterprise leaders have very little idea of what AI to trust, and the degree of trust people have. You had a very cool stat. I think that might be worth bringing up in this context.
Yeah. It's actually, let me, here it is right here. Actually, let me bring it up. There's two parts to it. What this is saying here is, if you look at the light blue bars, that's the amount of newly generated, unanalyzed enterprise data and how it's projected to grow. The black line is the human talent that is available to actually figure out and get value out of the data. So clearly there's a growing gap here, right? There's just not going to be enough human beings to do all this stuff. So you take that to one level further, I think this is the one you were referring to, Satya, where if you were to extrapolate today, only about 60% or so, or 60%, don't really trust the decisions that the data is telling them through their analytics. It's just going to get worse unless there's got to be a new way to do all this stuff, right?
Yes.
Otherwise, you're going to get more and more just a flood of data. And how do you trust in what's coming out of it when it's a tsunami, right? Just overtaking.
Totally. Yeah. I mean, so and the previous chart's also quite interesting. The one about the amount of data, zettabytes of data, and how little of it is analyzed, and how we have this massive talent shortage. In fact, I'm not entirely sure about all this discussion about job losses and everything else, when clearly there's so much room for people to come in and be data scientists and data engineers, and there's a big talent gap here. It's actually something that at Emergence we're actually very focused on, which is because there are problems where, one, because there's a big talent shortage, but two, even with the amount of technical talent that may be available, there's some problems that are simply not solvable by humans. There's a whole bunch of machine scale problems where you're getting something like 100 gigabytes a day from all kinds of manufacturing floors and all kinds of sensors, and there's all kinds of information that's buried in that data. And how would you analyze something like that in real time and get some real results? I think that's a great example of where AI and agentic AI can come in and do something really interesting. And that's definitely an area of focus for us here at Emergence.
Well, yeah, you guys are big time focused on helping people get value out of their data, among other things. And the way to help address that curve we were looking at is get agents to help turn people that aren't data scientists or data literate into being data literate.
Exactly.
Right. And
exactly,
so
yes.
to your point, I'm not one personally that buys into it's going to take everyone's job. I think, you're going to be able to save money for sure, but unless you want to go out of business, you should reinvest that money and you can do more. So you either save money or you do more. And if you give more and more people superpowers, and in this case, you give them more and more power to, empower them to actually get value out of the data, I think, that's how you address your biggest asset over time, is how much data and what intelligence you get out of it. So I'm with you 100%. And that's what's exciting about what Emergence is doing, is you're helping to provide that capability. It's going to get interesting.
Yeah, no, without doubt. Yeah, go ahead. Sorry, I didn't.
Yeah. We're gonna come back to Emergence. I just got a couple more questions for you.
Sure. Yeah.
Before we wrap up here, and actually one of them is, so I think what you're saying is, the journey forward into incrementally more reasoning capability is important, because you want agents to be more and more capable to help humans, and more than just doing tasks that Gen AI is doing today. I think the other side of the coin is this, and this is Identity and SailPoint, were the source of this, and it's basically saying that 96% of enterprises worry that if they start deploying these agents, of which some go off and autonomously act, where's the accountability? Where's the auditability? What kind of compliance controls? And do these things have identities? And are they tied to a human being who's actually ultimately accountable? And what credentials? I mean, how do you give them credentials to go get certain data or take certain actions? And how do you audit them? What the actions? And how well are they performing? And you need to start managing them as little as digital workers, right? So I think that's another big problem that I know you've mentioned before, and I agree that this needs to become on the forefront really quick too.
Right. Yeah. I mean, so I think what's worth talking about there is, currently, kind of the discourse in agents is somewhat dominated by, a bunch of use cases where you're essentially getting an LLM to do some read and write operations on some system, some ERP system or CRM system or so on. Okay, and generally that's fairly straightforward. Okay, so you're not especially, I mean, I don't even think of these things as agents as much as their workflows, their automations, simple automations, etc. And so and part of the reason why people aren't jumping up and down and worrying about that the point you brought up about trust and auditability is a lot of these are relatively simple automations, and certainly you just want to make sure that they're done right.
Right.
But where this becomes important is when you start talking about things like web agents, things that are autonomously going off and taking some decisions and creating some subtasks for themselves and going off and exploring. Okay, that's where the frontier of the field is, and there. I definitely think 96% of enterprises don't trust their systems like that is warranted. I think that stat is warranted. I think the fear is warranted. I mean, I've been in this field for the last 10, 15 years, and the very first time I've really taken AI safety very seriously is with agentic systems. Okay, it's not that I didn't take them seriously before, but broadly the points there were bias in data leads to biased AI algorithm outputs, and sure, yeah, I mean that makes sense, but when you have systems that can act and that can take decisions and that can reason and create goals for themselves, that's when all hell can break loose. Okay,
Yeah.
and that's something that we are very focused on, and it's something that I think the field more broadly ought to tune into and dial into. And this lack of trust that enterprises have is not only warranted, but it should basically set alarm bells ringing amongst people who are developing the technology.
Yeah. And one example of a business challenge, actually, Mark Strauss told me about this. He's the CEO of Proof Analytics, helping provide proof behind things, and he's doing causal AI and stuff like that. Is there was a fiduciary ruling in Delaware in the United States a couple of years ago, where if you're a corporate officer, you can no longer say, "Oh, the AI did it." No, you're accountable now. So you're accountable for your AI. And so that's going to say, well, God, well, I have to understand the AI better. I have to understand why it's doing things. I have to be able to explain it. And imagine having agents going off and doing things, but you're actually accountable from a fiduciary law perspective, right? So, things like that are starting to happen here, where I think this becomes, like you said, when you start getting things going off and doing things, and there's not always a human in the loop, or it becomes more mission critical business decisions that they're involved in, all this trust stuff's going to become more on the forefront.
Totally. I mean, look, I couldn't have said it better myself, which is the importance of the human in the loop, the importance of guardrails. So one of the things we did about a year and a bit ago is at the time, web agents were still relatively new. Adept had done some work a year before, and about a decade ago, some early work out of DeepMind, and even in the early days of OpenAI, there was some work on systems that can autonomously operate the web, etc. So we took that mantle and spent about 2 3 years really understanding how to build web agents, and then we open sourced an incredibly high quality web agent called Agentic. So if you Google Emergence Agentic, you'll find the GitHub link and you'll be able to see it. And we opened, and that was at that, and that particular agent had a lot of our IP in it, things like hierarchical planning and skills harvesting and so on. Okay, and we've since then improved that substantially. But the point is, we put that out there because we wanted people to see how you build agents and what are the guardrails and what are you enabling and what are you disabling, and the importance of the human in the loop, and right, all these things were things that we were really worried about, because we realized you have a system that can basically go and use a browser like a person. It can click, it can use the keyboard and mouse and enter terms in search fields, and inherit your permissions. And systems like this are actually dangerous, right?
Yeah.
And it's about building them with the right guardrails, having the human in the loop. So I think I like the Delaware ruling where you're responsible for the deployment of your agent, and the other point you brought up about how do you manage a bunch of digital agents that are running around doing things, right? So all these things are basically where one needs to really be very focused on if autonomous agents are to go off and do something significant in enterprise.
Yeah. I mean, a two-part question here. And this kind of gets me to AGI, like, stop worrying about AGI, I think, right? You got these real important business issues like we've just been talking about. But, at the same time, I'm curious too, why is AI moving faster than any other tech in history, so far, and even faster than other fields like, say, quantum computing, right? It's just moving so quickly. So I'm curious to your thought on that, and then also on what do you think of AGI, and where is that on our timeline here going forward?
Yeah. Look, I mean, I think let me kind of start with the first question. I think it's easier and less controversial in many ways than the second one, right? So why is AI moving so fast? I think it's look. I mean, like Ray Kurzweil in his book *The Singularity is Near*, which was an interesting book. Not that I agree with all parts of it, but certainly some parts of it were interesting and other parts were cherry picked to support his argument. Makes this observation that there's exponential trends that are happening everywhere you look, and but these exponential trends have a particular gestation period, a long gestation period before a number of things happen, and so you go from subcritical to critical all of a sudden, and then suddenly all hell breaks loose, right? So I'll give you one really fascinating example of this from my work and my very early work in my PhD thesis days, where we were doing things like gelation of liquids into solids. Okay, and I'll then relate it to AI and kind of the number of confluence of factors that came together. So what typically happens? Let's say you're making Jello, which all of us have had at one point or the other. It starts off as a liquid, and you're stirring it, and suddenly all of a sudden the thing gels. Okay, but in reality, all kinds of little networks are forming across this entire liquid, and you cross a particular threshold called the percolation threshold, and then these things all start connecting with each other, and the viscosity of the liquid rises, and then suddenly gels. Okay, and the last bit happens very rapidly, and you spend like the last several minutes bring this thing to a boil and slowly stirring the thing, and then all of a sudden the thing gels, right? In some ways, something very similar happened here. I know it's a fairly random example to talk about computing and AI, but what's interesting here is, look, Moore's law has been advancing, okay, and you've gotten a tremendous increase in compute power over the last 15 years, 15, 20, 25 years. And we've gotten to a certain threshold where you can now have incredibly high quality computing with tons of data, tons of networking, and all of them came together with a tremendous amount of human talent that also got produced over the last 15 years by universities, because as deep learning advanced, people saw the promise of the field. More and more people went to universities to get computer science degrees, and suddenly you have an abundance of talent, an abundance of compute, an abundance of data, algorithmic breakthroughs, and voila, we're in this perfect place where everything came together and a whole explosion happened, and people started building rapidly on top of each other. Okay, so that's why I think this field moved faster than any other field in the history of computing, and fields like quantum computing are maybe 20, 30 years from that place. That's my read, knowing a little bit about that field. As to AGI, uh, I mean, look, the way we think of this whole thing is there's a major conflation going on between generality of a certain set of tasks and generality of all tasks. Okay, what LLMs did so successfully is that they generalized next token prediction. They got incredibly good at next token prediction and even predicting the next 10, next 100 tokens. And that lent itself to generalizing their ability to understand language, understand images, produce code of very high quality. So some generation of certain tasks got generalized. But what the conflation that's happening is, just because they're actually outstanding at producing language or code or images, doesn't mean they're outstanding at performing actions in the action space. And we very much think of AI agents and agentic AI as technology that's in the action space. And the closest parallel to this is what's happening in robotics and self-driving, which is actions in the physical world. And agentic AI, as we're defining it today in a very narrow sense, is about actions in the digital world, right? So generalizing actions in either the physical or the digital world, I think we're quite far away from that point. Okay, so if a definition of AGI is that you will have universal learning algorithms that can perform any type of actions robustly in the physical or digital world, I suspect we're a decade away at a minimum. I'm not even sure we entirely know how to generalize at this point in time, to be honest. Okay, so that's my take on AGI. basically.
Yeah, a decade. The good news or bad news, depending which way you look at it, is a decade goes pretty quick.
Yeah.
So, well,
Yeah.
look. So, I want to make sure we talk a little bit about emergence before we wrap up here. And for the audience, you should go out to emergence.ai. They're doing some really interesting things. I think you're right on with the focus you have. So, why don't you just spend a little bit of time here, just what your company's all about, what you're delivering. I think that would be really useful for people.
Yeah, thank you, Scott. Yeah, Emergence is really focused on this idea that intelligent systems built with a particular focus can unlock an enormous amount of value in enterprise. And so, what we are really interested in is what is Agentic AI really capable of doing, and how robustly and how verifiably is it capable of doing this, and what are the kinds of problems you can solve, especially in things like data, analyzing data, structured and unstructured, semi-structured at scale, to unlock real value for enterprises. And more broadly, we're interested in kind of the automating a variety of IT tasks, because we're especially interested in this idea of agentic coding and what agents and LLMs' ability to produce code put together can do in very robust ways to solve problems today. And in the process, what we're building are intelligent platforms and systems that are not only stitching agents together to solve a given task from natural language, but also, as the case may be, creating new agents on the fly, and evolving and through an iterative self-play mechanism, learning how to solve multiple tasks within a given domain. Once it starts creating agents that it doesn't know how to solve in the past, once that capability evolves within the platform, it then basically evolves itself further. All of this is with the goal of creating a very robust set of solutions to enable things like everything from ETL writing to data migration to data transformation to building machine learning models and analyzing data and so on. So that's the general domain that Emergence is focused in, and our toolkit involves everything from self-play and self-improvement and reinforcement learning techniques behind those, to verifying to AI planning and AI verification as core first-class citizens that we're advancing in this process.
Yeah, you go back to those two charts we were talking about, which for the audience, you should know those were charts. And that's research that I did. I just thought was relevant because I went through the website and everything. But you are helping to solve those problems of the data is growing so quickly that how do you get value out of it? How do you get intelligence out of it? And I think that's another big part of, I think what you guys are really uniquely, I don't say uniquely, but I don't see as many of the agentic players focused on those particular areas. But it all starts there.
Yeah.
Without, there is no there is no AI without an IA, an information architecture. So you got to get to that data, right? So,
Exactly. I mean, that if you put the data foundation right, then you can do lots of things on top of it. And we're helping companies get that data governance and the data foundation right. And we're doing this with agents, so we can do this much faster, and you're not waiting a decade to do this.
Right, and much higher quality. All right. Well, final question: what would your advice be for enterprise leaders on what do I what should I do, and what's your advice about the so-called hype versus myth versus what's true about planning?
Yeah. So I think it all comes down to enterprise leaders need to ask a very simple question. How is this going to improve? What is the ROI here? How is this going to improve the outcomes that I really care about? Is this going to make me money? Is it going to save me money? And how? Okay. And if you ask those questions and you're incredibly focused on it, then you're forcing your vendors to explain what their solution can really do for them. And that's if we get this right as a field, both on the technology vendor side and on the enterprise buyer side, if you get this right, then the transformation can happen much faster. Otherwise, I think you put up a chart much earlier in the conversation. 75% of enterprise leaders are hesitant to trust AI and are confused about what to do with Gen AI. Otherwise, that confusion prevails. They don't know what they're being sold, because there's so much noise, and the vendors themselves aren't articulating this ROI very clearly. And as a consequence, they don't know what they're being sold and what they should buy, and that's hurting the entire field and at some level, basically. So it's if they can ask that question and they can keep vendors or technology providers honest, then we can make progress here as a field.
Yeah, well, we're going to definitely have to have you back, and we'll keep this conversation going, because I think this is on one end of the spectrum. Innovation cycles are moving at warp speed, and if you're at risk of falling behind. So the game is played in the field, not in the dugout. You got to get out and start doing things. On the other side is you got this challenge of hype and overpromise. And so what are the most critical things to focus on, particularly when there's so many different points of view? And obviously that'll shake out over time, I think, but it definitely is a challenging world, at least in the cloud world and SaaS and mobile and client server and IoT, all those things that came before. Sitting on the sidelines a little bit to let things shake out was probably maybe prudent, but now you just risk falling behind. So I think it really is a big dilemma, and that's why I think this is a really valuable conversation. So I really appreciate it. Thank you so much for being here.
My pleasure, Scott. Thanks for having me here with you.
Yeah, no, this was a really great conversation. I think it was meaningful and very insightful, and I definitely got some additional ideas to go off and do research. So anyhow, best wishes to you. Keep us up to date on the progress you guys are making there, and I look forward to future conversations. For the audience, thank you all for tuning in. As you've heard, we're definitely entering the golden age of AI agents. It's here. And I think the opportunity is no longer theoretical. It's real. It's growing. It's available to those with, clarity of vision and the urgency to act and get out there and start, playing around with this stuff and seeing what's possible. So again, thank you so much for tuning in. Really appreciate you. We'll see you on the next round of the Next Frontiers of AI podcast. We are the leader in tech news and analysis. Bye for now.
Thanks, Scott.